57. A 36.0 liter cylinder of a gas used for calibration of blood gas analyzers in medical laboratories contains 350 grams of CO2, 805 grams of O2, and 4,880 grams of N2. At 25 degrees Celsius, what is the pressure in the cylinder in atmospheres? Okay, so let's list out everything that we have, and then from there we could probably find a formula that works best. So they started us off with the volume. With gases, volume is very important, so I'm going to write that one down. Volume is 36.0 liters. And now they're telling us that it has all these different gases, right? So we have to write that down. So we have the mass of CO2. Actually, what I'll say is M equals, we have three different mass values, right? We have 350 grams of CO2. We have another mass of 805 grams of O2. And then we have another mass of 4,880 grams of N2. Now, they did give us a temperature. The temperature was 25 degrees Celsius. And they're asking for the pressure. Okay. So, I'm running through all of this. I don't have any sets per se because these three masses are different gases. So they're acting on their own. And I don't have like two volumes. I don't have two temperatures or two pressures. So the combined gas law is out. And I'm not looking for a molar mass or a density. So we're going back to the original ideal gas formula, which is this one. PV equals nRT. Now, it all stems from that R value, right? 0.0821. And the units for the R value lock all the other units in place. ATM times liter over mole times Kelvin. So the pressure has to be an ATM, P for pressure, and we're searching for the P. So we know that once we find it out in this formula, it's going to have to be equal to ATM. The V is volume, and that has to equal liters. And thank goodness they gave it to us in liters, so we're fine with that. So check on that. Now, N represents the moles, but they didn't give us any moles, so maybe I'll skip that over for now. The R value we're always going to have, and the temperature, remember, capital T is temp, that's Kelvin, but they gave it to us in degrees Celsius, so maybe the first thing that I'll do is I'll just convert Celsius into Kelvin, and we know how to do that, plus 273. If you want to be more specific, it's plus 273.15, but this is fine for me. So 25 plus 273 is 298. And now I have this. Now remember, we're solving for the pressure. So that means I have to know these moles. Well, here's a new idea, guys. I think all the questions before this, we were dealing with one gas, which was in a liter, right? It was in a vessel, right, with the given volume. So if we were dealing with one gas, we were dealing with that amount of moles, and that was the volume. But now here, we have a volume with a mixture of gases. We got three of them. So we can basically expand this idea that says if we're talking about a total volume in liters, the moles just have to be the total number of moles. So in here, they gave us the three gas values, right, and the grams of them, and I can convert all three of these into their corresponding moles, right? I can go from grams to moles of CO2. I can find out the moles of O2, and I could find out the moles of N2. And then by adding these up, that's going to give me the total number of moles. And that's going to be the number here. So let's go for it. We got 350 grams of CO2, and maybe I'll do these in a couple of different shots here. So let's see, we got 350 grams of CO2, we got 805 grams of O2, and then maybe I'll put the other one, let's see, maybe we squeeze it. Let's see here. I'm going to squeeze this up. And now this is coming up here. I guess we'll just put it over here. So we have 4,880 grams of N2. So remember, it's just times by the ratio. Times by the ratio. Whoop. Times by the ratio. Times by a ratio. And then grams of CO2 go on the bottom because I don't want grams of CO2 anymore. Grams of O2, that goes on the bottom. Grams of N2, that goes on the bottom. And then we're going to solve for moles. So mole of CO2, mole of O2, mole of N2. Remember, this is just a periodic table. You always have 1 mole, so 1 mole all around. And then the mass is whatever the number is on the periodic table. So let's see. CO2 would be 12.01 plus 32. So 44.01. O2 is just 32. And then N2 is 28.02. Okay. Cancel these out. The grams get all canceled. Goodbye. And now we are left with the moles. So 350 divided by 44.01. I have 7.95. And maybe I'll just move this a little bit over here again. So 7.95 moles of CO2. I have 805 divided by 32. I got 25.16 moles of O2. And then I have 4880 divided by 28.02. I got, 174.16 moles of N2. Mainly, the reason why we have so much moles of N2, for anyone that's wondering, is because air, right, is mostly contained of nitrogen gas. So that's why there's way more nitrogen than there is carbon dioxide and oxygen. But the main point is that we just found out the moles. So now, if we have moles of this, we could find out the total moles. The total moles would just be these 3 added together. So maybe I'll just put that down. So total moles equals the 7.95 plus, I'm going to, get lost the units, 25.16 plus the 174.16. So let's see. 7.95 plus 25.16 plus 174.16. So I have a total moles of 207.27 moles of my mixture. And that's what's going to go here. And now I finally have my N value. So what I'm going to do is pause the video, but I'm going to just erase my little conversions here. And the only thing I'm going to leave is just that total number because that's the only thing that we need. So bye-bye. I'm just going to bring this over here and do the math now. So we're looking for the pressure. So X times the volume in liters, which is 36.0, equals that mole value, 207.27. And then the R value is always constant, 0.0821, times the temp, which was 298. We want to solve for X, so all I got to do is just divide by the 36 on both sides. And then we are good to go. You could always get this as one answer, but I like to plug everything in into the calculator at once because I don't want any unnecessary rounding in the middle. So 207.27 times 0.0821 times 298. Divide that by 36. Right? It was 36 liters? Yeah, okay. Whoa. Really, really pressurized cylinder. We got, how many sig figs? I think 3. So maybe if I just say 1.40 times 10 to the second, aka 140. Actually, we need 3 sig figs. So actually I could just do 141. That would actually work better. 141 ATM. Or you could say 1.41 times 10 to the second. But this is easier. And there you go. That's the pressure of the gas. The mixture of the gases in the tank, in that cylinder. So 141 ATMs. So I really hope that this helped you guys. Let me know in the comments. Love talking to you guys. And if you want to help us out, press the like button, subscribe to the channel, and tell your friends, tell your classmates that this YouTube channel exists. Just gets the word out there that, this cool service exists. And I think it's pretty cool. What do you guys think? Thank you so much. And I hope you have a great day. Okay, bye-bye.